This is the assembly of your 3D printed parts for the 8-inch cabbing unit. On the original, this is the header piece. There's 2 holes on each side. These you tap with a tap, 1/4 20 for a bolt. This is the motor bracket where you mount your motor, your speed control. This sits down on the tank once it's completed. These holes here, you tap 1/4 20. I use 1/4 20, anywhere from 1/2 inch to 3/4 inch bolts to put the assembly together. This is your motor, or whatever motor you get. You can 3D print a bracket to hold that motor, and that will sit down in this pocket and be bolted in. Again, the holes 3/4 or 1/4 20 bolts. This is the arbor that is used. The bearings have been pressed in. Again, the holes are tapped 1/4 20. That will mount in here. The pulley for the arbor. Again, this one is 3D printed, and it depends on the type of motor you get as to what size you'll have to do for a ratio of the speed. Again, that green material that I was talking about in the original 3D print movie, this is the belt material sized for this particular unit. These are the side panels that go onto the head to keep the unit from sliding off the pan, to keep it in line when it's on the pan, the tank, where you are going to have your water. The master lap that you'll be using on the arbor. The arbor, this is made of 3/8, about 4 inches long to 5 inches long. The end of it is threaded 3/8 16. This is a piece of aluminum bar stock, about 1.5 inches long. We turn it down, the end, clean it, turn it down to leave a little collar on there that will ride against the bearing in the arbor. Put the shaft in real tight, put it in the lathe, and turn down this material here like this. This is a 1/2 inch here. Tap with a 1/4 20 bolt. To put all this together, we can start off by mounting this in there. Come to this side. Put your bolts in. This operation of what we're doing on the 8-inch is the same thing you do for the 4-inch and 6-inch. Same process, almost the same parts, except for the size. On the header piece, I would use no less than 75%. So I'm printing another set in there. They're done at 80%. Both this part and this part at 80%. The arbor itself, 100%, because that's going to take all the torque of your laps, your shaft, and your motor pressure. So we're together there. Now we want to mount this together here. So we'll go in here. Come on, find the holes. There we go. From the inside of the pan, the bearings are for a 3/8 inch shaft, and normally when I look them up on eBay, if anybody wants, they can contact me and I'll give them the exact site that I get the bearings from. But they're about 22 millimeter outside and about 9.6 inside diameter on the bearings. We tighten these up snug. And here's the thing, if you use the longer bolts, you can see how they come through. If for any chance they get weak or something like that, because this is a plastic, and you can put a nut on there to bind the two together. Okay, we have that mounted. Now we need the side panels.
So I suppose if someone didn't have a tap and die set, they could just use bolts and then use a nut to clamp it
Drill
together.
a hole, yeah, they could drill straight through and use the nuts. I give them the base to start with, and then they can modify, change it, however they need. I have one fellow that's doing a unit, and he's only has a small printer, but he knows how to slice things apart and then glue them together. So that's the way he's going to attempt to make his. So yes, there are different ways to do it. I use stainless steel bolts, Allen type, all the way through, simply because you're with water, and it's not like all the commercial made machines out there where you sit there and get rusted up. And then you can't get the bolt out.
Boy, do I know that one.
After you run the machine for a while, you might want to go back and just check and tweak the bolts.
So is this your capping machine that we're putting together?
Yes.
Yep.
Okay. And do you have a capping machine right now? So this will be an
I
extra
have a
one?
fastening machine. I have one of the Raytech fastening machines I bought secondhand, and it's a 6-inch.
Now, as you notice, I have an 8-inch master lap and also a 6-inch master lap. So you could use any size diameter wheels on this up to 8 inches. This is the water pump. I get the little China type, get them mounted in, and then I've 3D printed this little hanger here. This is an aquarium air valve, and yes, I do tap this right here and right here, so that when I screw this in, it won't get loose. And when you're running your machine, you want to get your water on there. So what we do is, this will be back in the back of the tank, come around like this, you can bring it up, you can put your knob down like that, and it's against your lap, and there's your watering. These valves are very good for adjusting the speed and the amount of water, so you don't have too much of a problem. To hold the lap on, I 3D print a knob with a recess, because if you remember, on here you have a 1/2 inch. So I make this deep like this, so when you screw it in, you can see it's going to go past that end. That's going to lock whatever different variations in master lap and your topper lap that you use. And what I do is, when I printed this, I printed a hole in the center, and I tapped that 1/4 20 and used a little short Allen set screw. This one here is probably about a 1/2 inch long, to put in there. Tighten it in as tight as I can get it, and then that's my lock on for my laps. Water tank is printed 3D. By the way, sometimes in 3D printing, you don't get it exact, and you might find something where you got a leak. You might try using paint or polypropylene spray or something in there to seal that hole off with, wherever it's leaking. So far, I've had no problems with it. I don't, on saws and cabbing machines, I do not use oils, I use water because it will not travel through the plastic. Oil sometimes can. So now we have that. We need to put in the arbor. Go inside here, put it in. There, we're all the way in. Now I'm going to leave it a little bit loose there because I've got to mount the motor. And the motor I mount in here like this. Screws here, and you can place these screws however you want. And in this case, I'm going to come to the back set of holes.
Okay, so there's 4 holes on the bracket that you've printed, but
Yes,
you only use
it depends
you only
on
use 2 of them.
how you want to mount the motor and what kind of motor you're going to put on there.
And I imagine that's all 100% printed fill as well.
Yep, and that's 100%. Okay, we have a pulley on it, 3D printed, although I would suggest if you can find this motor, you use a metal one, get a metal one turned, a small one. As far as the,
And that's because these get warm.
yeah, there. This is a retaining collar I make for the other end of the arbor shaft. Now, this is our total arbor with our shaft. Put that in there. Now I can put my pulley on. Because of the length of the shaft, I leave that loose. Now I put it all the way in. You'll see here how because of the size of the pulley, for that particular motor speed, I had to leave a gap back here. So now I'm there, I'm going to pull that tight and tighten that set screw. That will lock the shaft so that the shaft cannot move back and forth. Okay, so now I'll take and align this up. Now we're locked on. Now by using the elastic belt, I don't have to worry about adjusting this brackets here very much. So I just go ahead and tighten them down. Probably about 5 to 6 millimeter belt material. Okay, now we can set the tank down there. Turn it around the other way. And we can set that down in there. And it straddles like this. We could take the water here, put it down below, down in there like that, and you want to position it where you can get it fairly flat down in there. Move this back, we're in place. There's that. Now what I've done is I've gotten a cord, mounted it on there. With this particular motor, I've been using these box type variable speed controllers. This one says 220 on it, but it's almost the same circuit as the 110, so either one. And because of the direction of the motor, I'm wiring it backwards. Where it says positive, normally red is considered to be positive. In this case, I'm putting in the black one. The motor is bidirectional. You can run it either ways, clockwise or counterclockwise. I drill and tap a hole in the side here to mount this down in there.
Which that mount will depend on whatever speed controller someone's able to find.
Yep. You might find a different type motor, and then you can use a different type of power source of brick. This is basically 110 volt to 90 volt. The motor itself is a 80, 90 volt DC motor. When I tightened up the bolt, it shifted. So now I come in here like this, bring it up, bring it around. Bingo, we're on there. Now, if it's too tight, I can always loosen that and bring that thing over. Let's see what's going to go. Normally, they're not that noisy. There you go.
Magic.
So if it's louder than this with this kind of setup, then something is loose or
Yep.
a little funky.
They generally run quiet. The other thing you can do is if you're using different types of power cords, bring it in over here. What you could do is drill a little hole right here in the side of this, use a tie wrap and lock that on there, so that way this can't pull loose from back here or anything like that. Yeah. So basically there's the working machine. Now we'll turn it off. We'll put the large lap on. Now if we had a wheel in there, and that's why I said I put that deep depression in the knob. There we go. You got quite a large place in here to do your cabbing, wide open, easy to get at. If you wanted to, there are a lot of people out there that like to do intarsia. You could make a 3D design and 3D bracket that comes up just so high, over and down, but you make a lip on it that'll come up right there where your lap is, and you can make it so you can move it back and forth so that you could bring your pieces in there to grind the flat the way you want it. And of course, you have all kinds of speed. So if you got a sapphire or something you really got to grind away at, you have the speed. And if you want to slow it down for opal, down here calcite, something soft, there you go. And the lap you use on here, you could actually use on the vibra lap, or vice versa if you get the ones with the hole in it. The vibra lap, you could use the ones with no hole, but many people, you're on a budget, you could use the same lap. When you're not using the cabber, you could put it on the vibra lap and run it on the vibra lap. Like the problem you saw where the plastic pulley on the motor came loose, I would suggest that that pulley be made out of aluminum or a commercial, if you can find one that size for that motor. That way, that motor does get hot after a period of time of running, and that heat goes down the shaft and the plastic pulley might become loose. We had that happen at our Lapidary show, and that was on the Saturday. At the end of the show, our gal had made several cabs on the machine, polished them and everything. Turned around, I took that pulley off, came home, made an aluminum one, put it on the next morning. She had no more problems. And it ran just beautifully. We're still using the machine.
And at that size, like inch and a half or something.
Yeah.
That's not an expensive pulley if someone needs to buy one.
Not really, yeah. You can see you've got a wide open work area, and then you can see this. Here's another thing. You can move this wherever you want it and lock it in. When you're changing wheels, you can just take it off and drop it down in here. You don't even have to turn the water off if you were going from, say, a coarse wheel to a fine wheel. Now, what we'll do is turn this off. Don't drop it in the water. Now, see here, I can get, originally this part in here on my 8-inch was not open. And I finally decided, wait a minute, you want to get inside there. So I designed it so I can reach in underneath and grab a hold of the lap. What I did is I 3D printed these wheels. And you can, if you want, start out with TPU, the rubber type, a little bit. Stop it when you get a little bit, turn around, change the reel out for your regular PLA or whatever you're going to use, and finish 3D printing that. It's recessed here, and this is where you put your sanding. If you're going to be using silicon carbide, which is ancient, you could put that on there, or you could put other types of pads that are available out there. Bring it in here like that. Spin it on, get it started. There we go.
There's one way to cheat.
Yep. This is why I left the back open. I can grab a hold of this pulley and use it to tighten or remove the wheels. And there we go. Now we're set up for sanding.
Now, is that where you would put your polishing pad?
Yep. Simple and easy. Life expectancy, well, we got to wear one out. Somebody let me know. The only thing I don't do is I don't leave it sit in my car or any very confined area where there's no air circulation, where it can get up over 120. In this case, like in a car, you can get over almost 200 degrees inside your car. That can affect the plastic and alter it a little bit. I have one of the 8 inches where this drooped down to about here. It's still usable, no problem. But keep it out of a hot spot.
And this is just PLA.
I've used PLA. There's also the PETG, which is supposed to be a little stronger, and it is a higher temperature melting material. I guess there's other materials out there that people were talking about, the carbon fiber materials that you can get to print with. I don't have any of it. I haven't tried that yet. But there's unlimited possibilities out there for whatever you want to do. And like I say, you can modify this if you want. I might still have the FreeCAD designs that I did. The only thing is I cannot send them through the internet. They're too big, so I have to put them on a chip and send them to you that way. And you could take and enter it and then modify it any way you wanted to, unless you have a program to take the STL, or in this case the AMF type file, and take it back to the design CAD program and then make your changes. I have one fellow doing that. So like I say, it's a good usable machine. It should last you a long time. And if anything goes wrong, something breaks, or like I said, if you left it somewhere wrong and it warped, you can print another part, replace that part. The most probably troubling part in the whole thing that people will have is that shaft with the head on it, which is aluminum. That needs to be machined. That's not an item you can 3D print. On the saws, I've actually taken the shaft and 3D printed the head for the saw, because what the problem is when you put this in here, you notice I screwed it in on the I screwed it in on this. If this is 3D printed, this part here, it snaps off because it's so long. Whereas on a saw, that's not a problem.
When you were talking about it.
Yeah. You can attempt to 3D print the end to mount your laps on, and this one here I made so you can put it onto a motor shaft. You could drill a hole in here and put a set screw to lock it on that motor shaft. For doing typical cabbing, it should work fine. Putting your lap on, holding it on. That'll be fine, but you cannot use it with this system for sanding and polishing because that little knob that sticks out is plastic. And the torque of this on there would bend and it would snap it off, whereas this would not.
Okay.
You can use your 6-inch Crystallite makes a package of pads with diamond compound and discs and everything. And you could take and put that together and do your sanding and polishing with that. There's other companies that make the resin bonded pads that you could glue on to your disc and do your sanding and polishing with. There's your water for your, because the resin bonded ones you use water on. So there you go, and that would work on there just fine. When you go to get a 3D printer, I've used the Ender 3s. You can do the small cut down version of the 6-inch. You can do the 4-inch saw on it. You might have to shorten the table a little bit in the slicing program. That's about it on that. The 4-inch one you can do on there, a cab or two. But most of your machines, if you want to do a regular 6-inch and what have you, at minimum of a 300 by 300, and my personal recommendation is the 420 by 420s that are out there. Any cubic, and preferably I'm starting to use the Elego Neptune 4 Max, and I'm finding less problems with it. NV Liquidations in Las Vegas, Nevada, and they sell 2 for 1, and basically they're just parts from 2 different machines. And they guarantee you will be able to build 1 machine working out of the 2. Well, the second one, it can be backup parts, but I found that sometimes you end up with 2 good working machines, or at least 2 complete machines with one with a minor problem, firmware problem. So there's a lot of stuff that you can do. But with the big one, there's no question about what you can do. I print the 10-inch saw on there. I can print up to a 14 to 15-inch Vibrolap on it. The size of the machines, I could probably do a 10-inch at least cabbing unit on it instead of the little 8-inch and 6-inch. So that's how big you can go. You could also, if you're into doing flat lapping, you could 3D print yourself a 10-inch flat lap or even larger. The building plate on those are 16 3/4 inches building surface. So yeah, you could almost make you a horizontal flat lapping lap about at least 15, maybe 16 inches without a problem. Just sitting down and using a CAD program, design it up, and then print it. Put your parts together, and away you go. It's unlimited as to what you can do in the lapidary as far as creating your own stuff, designing your own machines and your own methods.